This equation has a fractional exponent, and if you remember what fractional exponents represent, they are actually a radical, just written in a different form. So we can use the same rules that we have for solving radical equations to solve this fractional exponent equation. Your first step when you are solving a radical equation is to isolate the radical by itself. So we have a 3x to the 3/2 power. The exponent is 3/2. Directly below and to the left is the base. That is the x. The 3 is not part of the base because it's not in parentheses. So we have 3 times x raised to the 3/2 power. And I need to get this base and exponent isolated. That's the same thing as our radical. So I want to divide both sides by 3 to start. That would give me x to the 3/2 power is equal to 125. And then from there, I'm trying to solve for x, so I need to get rid of that 3/2 power. How do we undo that? Well, when you have a fractional exponent, it's really easy to go through and solve. We want to raise both sides to a power, and in order for us to undo this 3/2, the power that we use is its reciprocal, which it would be 2/3. So with a fractional exponent, once you get it isolated, the base and the exponent all by itself, then you're going to raise both sides to the reciprocal power. And the reason for that is we have a property that says if you have a power to a power, you multiply those together, and anytime you multiply reciprocals, you get an answer of 1. So we would have x to the first power, or just x, which is what we were trying to do. We were trying to solve that. So x is equal to 125 to the 2/3 power. From there, we want to simplify that as much as we can. And to do that, we need to recognize what the 2 and the 3 up in the exponent there represent. The bottom number is our index. So this is actually going to be a cube root at some point. And the 2 that's on the top, that is an exponent. So we are going to be squaring. So we have 125 to the 2/3 power. And how you could write that if you were going to break that up is we have a 3 on the bottom of the fraction, which means we have a cube root here. And we have a 2 on the top, so it's going to be squared. The cube root of 125, well, that's just 5. So you get 5 squared, or 25 for your answer. When you're done solving a radical equation, you do need to sometimes check for extraneous solution. It depends if your exponent that you raised both sides to, if that is even or odd. And in this case, we raised both sides to the 2/3 power, which is not even or odd. So how do you determine what that looks like? Well, the bottom number, that is your index, so that's a cube root, and the top number, that's your exponent. So take a look at when you raise both sides to a power, and you want to look at the top number only to determine if you have to check this or not. Our top number is 2, which is even, so we do need to check our work on this problem. Because we raised both sides to an even power. Plugging 25 back in, we would have 3 times 25 raised to the 3/2 power equals 375. 25 to the 3/2 power, you could throw that into your calculator. Otherwise, remember the bottom number is your index. So it's the square root of 25, which is 5, raised to the 3rd power. 5 to the 3rd power is 125. And 125 times 3 is 375. And that confirms that 25 is a solution to this problem. We have another fractional exponent in this problem. Remember, a fractional exponent does represent a radical, and we do need to isolate that. So the base here is the x minus 3. The exponent is the 1/3. I need to take the 2 and the plus 3 that's here, move both of those over to the other side. So let me start by subtracting 3 on both sides. And then we can divide both sides by 2 to get rid of the 2 that's being multiplied by our base. That gives us an x minus 3 to the 1/3 power is equal to 2. And now I have my base and my exponent isolated all by itself on the left side. With our fractional exponents, once you get that base and exponent isolated, you're going to raise both sides to the reciprocal power, the reciprocal of whatever this fractional exponent is, and the reciprocal of 1/3 is 3 over 1, or just 3. So I'm going to cube both sides. On the left we have a power to a power, and 1/3 times 3 just gives us 1. I knew that already because these are reciprocals, and whenever you multiply reciprocals together, you get 1 for an answer. So on the left side we end up with x minus 3, and on the right side 2 to the 3rd power is 8. And to continue solving, getting this x by itself, we can add 3 on both sides. That would give me x is equal to 11. I should double check and see if we need to check our work for extraneous solutions. So I'm going to go back and look at the step where we raised both sides to a power. And in that step I cubed both sides, which is an odd number, so I do not need to plug this back in and check my work. There's no possibility of extraneous solutions in this problem.